Hey everybody, this is Larry. This is me going with Stone Game 5, the recent Q4 hard problem with the Leetcode contest. Hit the like button, hit the subscribe button, join me on Discord. So one thing I'm a little bit sad about is that I feel a little bit bad that I keep on doing this, where I actually don't know the proof for this problem. It feels like, so I'm going to go over it and you'll see what I mean by a second. To be honest, so I end up taking about 17 minutes on this problem. To be honest, I spent about like 14 minutes or something like that. You could watch the live video afterwards. Just trying to figure out something that's n square or n log n, or sorry, n square log n, or something like that. Something that's faster than n cube. And why do we need to be faster than n cube? Because n is 500. But to be honest, I think there's some sort of, a lot of these states may not be reachable. So because of that, it's probably not n cube. I don't know how to do the tougher bound on this. My guess is that it ends up being roughly n squared log n, just because you remove half of the possibilities every time. So half the states at every level don't get caught. It's a little bit hand wavy. And because this is a hard problem to analyze, and like I said, this is why I spent 14 minutes doing it, and I spent 3 minutes just kind of YOLO implementing the n cube solution, and then submitted, and it worked. I don't really have a great explanation for that, but let's go over the recurrence real quick. So the recurrence is actually pretty naive, and I really wish that, to be honest, this is one of those problems that I consider not that great, because especially in Python, I'm pretty sure. I have to take a look later, but I'm pretty sure that my code is very close to the time limit exceeded, where in other languages it might not be. But some of it is like, maybe you should believe in yourselves. I don't know. Because like I said, it took me about 3-4 minutes to implement this, maybe a little bit longer because I think I had work, but a lot of time just trying to figure out the n square solution. And I only tried the n cube quote unquote solution because I couldn't figure anything out. So I was like, okay, may as well just try. But the first thing I do is I set prefix sum. But the recurrence is basically you divide. This is a classic subdivision dynamic programming, and then for each subdivision you just try all possibilities of the things in the middle. So basically I start, if left is equal to right, then you have one node left, then it's 0. And one thing to remind you is that, this is inclusive left and right. So sometimes you have to figure out what your left and rights are, rather than inclusive or exclusive. Otherwise, you're going to run into a lot of off by ones. And I actually messed this one up because I knew I had to do it, but I was just worried about running time, so I didn't really worry about the correctness. But basically this is the code. The recurrence is that, given a function of the left and the right boundary, we just brute force what's in the middle. Maybe I'll figure out the recurrence after this, actually. But yeah, basically you keep track of the sum of the left and then the sum of the right, and then for every stone that you kind of pause, you just kind of move them over from the right to the left. And then this is just in the problem description, which is that if the left sum is bigger than the right sum, you do this thing. If the left sum is smaller than the right sum, you take the left. And then if they're equal, you just take the best out of these two. So this is going to be the most expensive one, but because the stone value cannot be 0, this cannot be called more than once per thing. So that's probably okay. So, okay. I know that I hand wave a little bit because this is actually a pretty straightforward dynamic programming. If you do have trouble understanding how to come up with this, definitely practice more dynamic programming problems. But the hard part for this one particularly is try to figure out the recurrence and the math, which is what I struggled with a long time, right? So how many possible inputs are here, right? So the possible number of inputs are n squared, right? Left, right is n choose 2, but roughly right. Number of possible inputs, right? And then so this is also going to be also the space complexity, for obvious reason of, well, those are the possible inputs. You store one value for each input, right? And then the question is, how much does this take, right? So this is O of n because you do a linear loop. But so the naive interpretation of this algorithm is n cubed, and that's probably what stumped a lot of the top, or maybe not top, but the mid people, because this, well, a lot of people like this should, because honestly, if n is equal to like 100 or 200, I bet you that a lot of people would have gotten it within 5 minutes, including myself, I think. And then I don't know, maybe it's not the best problem though, but as a result, the question is this true? Are there n squared possibilities, right? And that's going to be a homework for you at home. But I believe that these are the number of possible inputs, but not all of them are reachable. And what I mean by that is that there are a lot of possible inputs that are just not possible. For example, in this input, like there's no possible way to go from 0 to 4. Like this will never be an input, because if you divide it along those lines, you have to choose the right? So there's some almost like, so you have a recurrence of kind of something like this, where, you know, O of n plus something like that. So that's I mean, I'm hand waving a little bit because it's a tricky recurrence, but that's kind of the math, and I think that's why it becomes oh, and actually I messed this up. And if you do the math, I guess it ends up being n squared log n, I want to guess. Those of you with the master theorem, let me know or come up with the recurrence. Let me know what you think about the complexity. But yeah, but to be honest, at the end, I just kind of implement the naive-ish dynamic programming. And I mean, I took a long time, but if you watch me live afterwards, a lot of it was just thinking. And as soon as I got this, like, yeah, I had an off by 1 here and there, but yeah. Anyway, that's why for this problem. Watch me solve this live next. Okay, well, they're lucky then, good. do minor research. That's in sketch binary search. I prove it. Do we always want to? So the n cube one is obvious, but n cube is too slow for 500. Let's do n cube. Well, people got this one really well, but I'm missing the recurrence a little bit. Up, bottom up. trying to see how fast people solve it for maybe inspiration. People solved it pretty quickly, so that's not it. So it must be an obvious recurrence that I'm not seeing. I'm gonna just type it out. Maybe. Not right though. Oh, wait. I guess they're the same anyway. That's not right. That's not that. It's 25, so it should be. That's a little bit too slow though, I think. Maybe not. Hey everybody, thanks for watching me solve this explain these problems. I have a video for this contest, for the screencast. Let me know what you think. Hit the like button, hit the subscribe button, and join me on Discord, ask questions, have fun, and I will see you on next contest. Bye bye.